Dear students, in this session, I'll be discussing the very important aspects of this particular unit, and also I'll try to solve certain problems to make the concepts clear. This unit deals about linear differential equations of second and higher order, because we studied about the first order in Unit 2. Now, it is better idea to start with one problem, how a typical question appears in the examination from this particular unit. Okay, so I'll start up with a problem. The question comes like this: solve d square minus 3d, okay, or else solve d square plus 4 of y is equal to 4 sine 3x plus e to the power of 2x. Solution. In one problem's solution, okay, in this problem's solution, I would like to tell how the broad solution appears. Means I would like to say how the solution appears in a broader sense. Then I will discuss about other situations where instead of sine x square comes and instead of e to the power of 2x some other function of x comes here. First of all, given differential equation, okay, is this as it is. I'll copy d square plus 4 of y is equal to 4 sine 3x plus e to the power of 2x. This is number 1. So auxiliary equation of number 1 is m squared plus 4 is equal to 0. Basically, when you substitute d as that m, you will get some equation. It may be third degree, fourth degree, fifth degree, second degree, depending upon this particular degree of f of d. So you need to first find the roots. M square is equal to minus 4, and because it is negative, the roots will be complex and the roots will be m is equal to plus or minus square root of this minus 4 implies m is equal to plus or minus 2i. Now 2i, I will write it as 0 plus or minus 2i. Now comparing this with a plus or minus ib, you know how to write the complementary function. That right hand side is some non-zero function. That is why we will have two parts, yc and yp. So yc will come from the roots of this auxiliary equation. What is the format for this one? That is nothing but e to the power of ax into c1 cos bx. For this pair of roots, this will be the part of yc, c2 sin bx. If there is another pair also, or if there are other roots, some other parts will follow for this yc. Now for this particular pair of roots, 0 plus or minus 2i, yc will be e to the power of 0x into. Because e to the power of 0x is 1, I may avoid writing this one. I can simply say that bracket value itself. So c1 cos, b value is 2, so cos 2x plus c2 sin 2x. So I am rubbing this because you understood that it's there and it will be there in your notes, and just I am touching the important concepts right now. And now yp will be equal to 1 by whatever function of d is there on the left hand side, that will appear here as a denominator, that is d square plus 4, and the function on the right hand side is 4 sine 3x, 4 sine 3x plus e to the power of 2x, e to the power of 2x. The first fundamental idea is to separate. Depending upon different functions, you have to separate it. So 4 comes out 1 by d squared plus 4 into sine 3x plus this 1 by d square plus 4 along with e to the power of 2x. That is equal to. What is the working method in the case of sine and cos? This sine and cos, only these two trigonometric functions we deal with in short methods. Other methods, other functions, for example cosecant or secant or tan or cot, will be using general method of solving. But for shortcut we have option in two methods, that is sin ax and cos ax. Whatever a is there here, these three, you have to square that, and after getting that 9 you have to apply minus. So minus 9, that is minus a square, to be substituted in the place of d square. This is the working method for sin ax and cos ax. So this 3 finally gives minus 9. That minus 9 should be substituted in the place of d square. So I will be getting that as 1 by 4 into minus 9 plus 4 minus 9 plus 4 of sin 3x, as it is copied. There will be no change. When the denominator becomes 0, that case is here. For example, d square plus 9 of sin 3x. Then this 3, if you take as a, then minus a square will be minus 9. If you substitute minus 9 here, it will become 0 case, okay, in the denominator. That I call as special case. Special case. In special case, you can use the formula 1 by d squared plus a squared sin ax is equal to minus x by 2a cos ax. You remember that d stands for derivative, 1 by d stands for integral. So integral of sin is minus cos, that is why this minus is appearing and sin is becoming cos. Similar formula you will have cos here, then it will be plus x by 2a sin ax. I am not discussing to save some time. So you have to give a reference of that one. So what I will do now is just I will clear off this frame. Directly I come back to this one. I am substituting minus 9. There is no 0, so it is a normal case. I call it as a normal case. So 4 into 1 by minus 9 plus 4 of sin 3x. Sin 3x. And here also there is a different method for exponential. Now here also there are two cases, normal case and special case. Denominator becomes a 0, that is a normal case, that's a special case. When it's not equal to 0, that's a normal case. So you substitute 2 in the place of d. The working method for exponential is that number will be just substituted in the place of d. So if you substitute 2 here in the place of d, you will be getting 1 by 2 square plus 4 of e to the power of 2x. So that is 4 into, this will become minus 5. So minus 4 by 5 sin 3x, this will become 8. So it is 1 by 8 e to the power of 2x. This is nothing but the particular integral yp. Therefore general solution is y is equal to yc plus yp. You need to write that yc value here and then that yp value, where c1 and c2 are arbitrary constants. Now let us talk about a case where we are having a polynomial. Suppose the question comes as solve d square minus 6d plus 9 of y is equal to x square or 2x plus 3. Simply 2x plus 3. This complete is a polynomial of first degree. Now in the solution you will be getting the auxiliary equation. I am not writing all steps here to save some time. M square minus 6m plus 9 equal to 0. So you will be getting two repeated roots now, real and equal. Complex pair we have done just now. Now this is real and equal case. So therefore the value of yc will be equal to c1 plus c2x e to the power of 3x. If 3 is repeated 3 times, it will be c1 plus c2x plus c3x square, and it is e to the power of 3x. Instead of that, if 5 appears 3 times, 5 comma 5 comma 5, up to here it will be same. Instead of 3, it will be 5 here. Okay, about this one, I feel that you got the point. So now I am proceeding only to this particular case with 2 repeated roots. If the roots are different, for example we have 3 and 4, then we will be writing yc is equal to c1 e to the power of 3x. Separately we will write that x. Okay, that exponentials will write separate. If it is repeated, then we have to follow this pattern. It is like actually e power 3x is one solution and x e power 3x is another solution. And if it is repeated another time, then x square e power 3x will be there. Taking e power 3x common, it is becoming like this. Back to the point. So we have discussed all the three cases when the roots are real and equal, real and unequal, and also when the roots are complex. Now there are certain cases where we will be having m is equal to 2 comma 2 comma 3. Then you will be writing yc is equal to c1 plus c2x because of this pair getting repeated, e to the power of 2x, and this instead of 3 I'll write 8, then it will be c3 e to the power of 8x. If 3 is there, it will be 3 here, whatever. So finally a detailed discussion is over on how to write the complementary function yc. Now we will move towards finding the yp when a polynomial is given. So in this case, now yp will be equal to, okay, I'll better write in the next slide. Now yp is equal to 1 by, just I need to write that function f of d here, d square minus 6d plus 9 of 2x plus 3. 2x plus 3. Keep in mind, for trigonometric function the rule is different, for exponential function the rule is different. Okay, and better I will do one thing here. I will add one function, okay, on the right hand side where e to the power of 3x is there, because 3 is repeated root here. I want to include that particular case with a special case. Okay, so now yp is this one plus this complete is yp now, e to the power of 3x. I'll now divide, or I'll break into two parts now, that is d square minus 6d plus 9 of e to the power of, sorry, this first part, anyway you can write anyone first, anyone next, but some students may get confused, so that's why I came back to this one. This into e to the power of 3x. Now separately we will calculate this one, individually we will calculate this one, and we will add up to get the value of yp. Now the value of this let us calculate. I'll do it in the next slide. Better I'll finish off this part first. Now 1 by d square minus 6d plus 9 of e to the power of 3x. I said earlier that when you have exponential, just substitute that a in the place of d if it's a normal case where denominator does not become 0. So we have done it. But here if you substitute that 3 in this 3 in the place of d, it is going to become 0. Whenever exponential comes, be careful, try to go and visit the roots before substitution and check it. Yeah, 3 is a root, therefore it will create a problem, and hence don't substitute and try to write it in the form of factors. 1 by, because 3 is repeated, it will be d minus 3 into d minus 3, that is d minus 3 whole square into e to the power of 3x. Now whenever d minus a power k comes, d minus a power k and e power kx is here, e power ax is here, that a substitution here makes it 0. So whenever this case comes, what you do is you multiply x to the power of k by k factorial to this e to the power of ax, that is e to the power of 3x. Because it is repeated 2 times, I will just take the k value as 2. So what I am doing now is I am taking x square by 2 factorial. Now we will have some small touch about this case. If d minus 3 whole square into d plus 4 is available and e to the power of 3x is the function. So what I now do is, because of this 3 becoming 0 here 2 times, I will multiply x square by 2 factorial, and then I will take up that 3 and I will deal with the normal case, that is 1 by 3 plus 4 e to the power of, okay, e to the power of 3x as it is. On simplification you will get that value. Back to the point. So this particular this part of yc is yp is calculated and we have got this one. So now we will move towards the second part, that is Now 1 by d square minus 6d plus 9 of 2x plus 3. This is what is this term. Okay, now I am calculating for this term. So what I do now, whenever a polynomial comes here, then expand this in the form of a series containing powers of d. That can be done only when if we take the least power. Here d square term, d term, and here it is constant. So least power term you take common, then 1 comes. We are in need of this one. This one is very important for us. Plus remaining as it is, you write it d square minus 6d and then divide with this 9 which is taken common. So 9 gets cancelled, you will get back that expression as it is, and 2x plus 3. That's equal to 1 by 9 into, it is looking like 1 by 1 plus alpha. 1 by 1 plus alpha expansion is 1 minus alpha plus alpha square, so on. And 1 by 1 minus alpha expansion is all of them plus 1 plus alpha square plus alpha cube, like that. Because it is 1 by 1 plus alpha, what I now do is I will expand this in the form of 1 minus alpha. So it will be 1 minus alpha. Alpha is d square minus 6d by 9, and then alpha square d square minus 6d by 9 whole square, then cube. But be careful, when we have only first degree term, expansion is enough up to here. But even if if x square comes, I need to write about this term. So I written so that you can deal with even that particular case. So actually in this case we require only up to here. So anyway, if this concept is understood, then you will be able to expand it up to x cube or x power 4, whatever it is. So how much degree terms are there here? It is highest degree, or simply it is a first degree polynomial, therefore I need only up to here. Anyway, I have written that to explain you about a second degree polynomial. So 1 by 9 into, now what you do is, this complete expansion we need only up to powers of d, that is only we need up to power d power 1. So neglect d square term. So d square by 9 I will neglect. I will write only 1 plus 6d by 9. So 1 plus 6d by 9. Now the remaining d square by 9, here d power 4 will be there, d cube, that all terms when operated on first degree polynomial, they will contribute only to 0. That is why we are not writing them. Now this is 1 by 9 times of 1 time of this one and then this times of this one. So what we'll be getting is 1 time of this 2x plus 3, that is 2x plus 3, plus 6 by 9 times of d of this 2x plus 3. D of this is nothing but d by dx of 2x plus 3. So it is simply 2, which is the derivative of 2x plus 3. So I am writing just 2. Now just that simplification, some polynomial will appear, that is the value of one more, that is the value of one part of yp. So you have to write that 2 parts. You calculated this part, you calculated this part and also you calculated this part. I mean to say that we are ready with both the values, this value and this value, just add up, that will be giving you yp. So once you get to yp, then substitute that yc and yp to get the value of, so finally you will get the general solution as y is equal to yc plus yp. So we discussed all the 3 cases. When polynomial comes, you have to go for series expansion, and when sin ax or cos ax appears, d square to be replaced as minus a square. When e to the power of ax appears, this is actually normal case, and a special case you have to use the formula that x by 2a or minus x by 2a. This will be appearing and sin will become cos, cos will become sin. I am not writing full detail here. Just remember this normal case, d square as minus a square. In special case, it is this one. I think I discussed here with this case. Did I tell about that? Here you have substituted, and I think I didn't say about that here to save time. You know about that case I'll write it here. Better I'll discuss that here itself. In the special case, one of the two situations arise, that is you have to use this formula 1 by d square plus a square cos ax is x by 2a sin ax, and 1 by d square plus a square, these two comes under special case. Actually if you substitute minus a square here, you will be getting 0 in the denominator. Then this value is directly replaced with this one. There is a long proof about it, leave it. So it will be minus x by 2a. Whether the proof is short or long, I'm sorry, I should write first here sin ax, then that is minus x by 2a cos ax. So this is for sin or cos, and for polynomial there will be no issue of denominator becoming 0, because we will expand in the form of a series expansion. This is the work for dealing with polynomial. For sin or cos, this is the work, and for exponential I'll write it here itself. For exponential means e to the power of ax case. Again there are two cases, that is normal case and special case. I'll write it here. Normal case, d value equal to a. In the special case, what you have to do is 1 by d minus a power k e to the power of ax is to be replaced with x power k by k factorial e to the power of ax. If some other factors are there, that comes under normal case, then you substitute d value as a directly in that remaining factors. So some remaining will be coming 1 by some d plus 2, something like that, okay, that which is coming under normal case. So keep in mind there are only these three functions which are discussed in our syllabus. Now we can have possibility of products of these two. Sine comes with exponential, or exponential comes with this polynomial, or polynomial comes with sine or cos. When polynomial comes with sine or cos, the problem is bit lengthy. You have to use that imaginary part concept to deal it with. So better I am not touching that case because of saving time. I will touch one case where both can be discussed. Exponential comes with polynomial, or exponential comes with this one. So out of three possibilities, these two possibilities falls under the same case, that is one function is exponential. What I mean to say that, I'll just touch up in one problem, that is suppose if the question comes to solve d square plus 4 of, or better I'll include some more terms in this one, that is d square plus 3d plus 2 of y is equal to e to the power of 2x, some constant 4 into sine 3x. Now just I'll write the part yp, because you are all clear about yc, d square plus 3d plus 2 4 e to the power of 2x into sine 3x. Now what we do is, this 2 we will add up in this d. Whenever this exponential comes before the operator, this complete is operator. So when the exponential comes before the operator, however constant comes without any problem. So that particular constant is 4 as it is. When the exponential comes on this, there is extra burden on sine 3x. That extra burden is d will become d plus 2. So this has to bear that extra burden now. 2 units extra burden. Okay, plus 2. D is replaced as d plus a, comparing with e power ax. Okay, so sine 3x. Now what happens? That is equal to 4 into e to the power of 2x into 1 by d square plus, okay, this is d square plus this 4d and this 3d becomes 7d, and this 4 plus 6 10 plus 2 12. So plus 12 of sine 3x, sine 3x. So sine 3x. Now I would like to make the point clear that this much of the part is nothing but 1 by f of d, some function. So it has to be dealt as like previous cases. So I'll write one step and I'll then leave it to you. 1 by, what is the working method for sin ax? Then normal case you have to substitute d square as minus a square. In special case you have to use that concept of x by 2a or x by minus x by 2a. So this is just falling under normal case. So normal case means denominator does not become 0. So you substitute minus 9 in the place of this. So minus 9 plus 7d. You are substituting only in the place of d square, not in the place of d. So sin 3x will be as it is. Now what we do is 4 into e to the power of 2x. This 7d plus 12 minus 9 becomes 7d plus 3. So I will multiply with 7d minus 3 and 7d minus 3. And then sin 3x will be as it is. This will become 7d minus 3 in the numerator. Denominator will become 49d square minus 9. Again d square is replaced with minus 9. So finally you will be getting that. You can understand this case. Okay. So I will write one more step for the sake of clarity. This one. So 7d minus 3 will be there in the numerator. 7d minus 3. And in the denominator 49d square minus 9. So directly I am writing 49 into d square value, that is nothing but minus 9. So minus 9 minus 9 of sin 3x. Now this complete becomes a number. I am least bothered about that number. So e to the power of 2x. Now what you do is 7 times of derivative. 7 times of derivative of this one, that is 3 cos 3x, minus, when 3 is operated it will become 3 sin 3x. So now you do the simplifications, you will get that result. This is nothing but the value of yp. So yc and yp if you add up, you will get general solution. And instead of sin 3x here, if suppose polynomial is there, that polynomial will appear here, that polynomial will appear here. So what happens is that polynomial will appear here. So instead of substituting minus 9, you will deal with a polynomial, that is you will take 12 common, then d square plus 7d by 12, and then you will continue. So this is how we will do that problem. So this particular unit has certain blocks. Okay, block 1, I am treating them as block. So block 1 is solutions of linear differential equations, homogeneous and non-homogeneous. These things we have finished. This is one block. And in block 2 we have Cauchy-Euler equation. Cauchy-Euler equation. This Cauchy-Euler equation is such that you will have x power n, d power n. This power will be same, plus some constant into x power n minus 1, d power n minus 1, like that. So to pn of, okay, pn that into y is equal to some q of x. Now how to deal with this particular concept, I will give one example. I will touch the beginning and then you can follow very easily. So I'll talk about that at some later point of time, after some time. Okay. And block 3 is dealing about method of variation of parameters. And one more block that deals with the method of reduction of order. These are only the main things in this particular unit. So this part we have finished. Now I will deal one by one about this part. So Cauchy-Euler equation. Okay, now I don't take much time. Please wait for a little time. So now we are dealing with Cauchy-Euler equation. Generally a question a question appears like this: solve some x square d square plus from 4xd plus 2 of y is equal to e to the power of or x square plus 1 plus 2 of y. Okay, so simply what you do in this case is, given differential equation is this, you write it to x square d square plus 4xd plus 2 of y is equal to x square plus 1. That is number 1. Tell that number 1 is Cauchy-Euler equation. Once you identify that it's a Cauchy-Euler equation, immediately take the substitution. Let x is equal to e to the power of z, and assume a new symbol theta, that is d by dz. However, we know that d stands for d by dx. Then the relation between this theta, this d and this x is that then xd will be equivalent to theta, x square d square will be equivalent to theta minus 1, so on. X cube d cube is theta into theta minus 1 into theta minus 2. This is happening under the substitution x is equal to e power z. Therefore, equation number 1 becomes this particular one. So wherever x is square, okay, Cauchy-Euler equation simply. So this x square d square I will replace with theta into theta minus 1, and then remaining constant as it is plus 4, and xd I will replace with the theta, that is this one, and that remaining constant is plus 2, I will write as it is plus 2. This complete is y. Y is not changing. There is a relation between only x and z. That is why this z and x relations we have written here. Okay, these relations. Now, in the place of this particular x, I will substitute e power z. So this will become e to the power of 2z. Plus 1 is plus 1 as it is. Wherever x is there, you substitute e power z. If z appears, then you write log x. Just applying log x is equal to z. Back to the point. This equation to be now simplified. This becomes like theta square minus theta plus 4 theta will become plus 3 theta, and plus 2 of y is equal to e to the power of 2z plus 1, and this is equation number 2. Now I hope all those students, those who have even little concentration listening, they'll identify that this is nothing but same like d square plus 3d plus 2 of y is equal to e to the power of 2x plus 1, because it is x here and this is d by dx, and it is z here and it is d by dz. So you have to solve this and you will get the relation of y and x. Here if you solve, you will get the relation between y and z. Once you get the relation between y and z, z you replace as log x or x you replace as e power z, then you will be getting back the final general solution. So first of all, write the general solution for equation number 2. Once you write equation number 2 general solution, then you get back that substitution and you get the relation in terms of x and y. So this is how we dealt with the Cauchy-Euler equation. So Cauchy-Euler equation is having variable coefficients, but it is reducible to constant coefficients. So we have done up this part. Now just in short time we will be touching these two, and my point is don't touch these two methods unless and until it is asked in the examination. Method of variation of parameters and method of reduction of order. So now let us talk about method of reduction of order. Method of variation of parameters first. Okay. Variation of parameters. In the examination they'll ask, okay, do it by the method of variation of parameters. So suppose for example the question is solve d square minus 4d plus 3 of y is equal to 3 tan 2x. Just I am writing dummy problem, okay. So if it is tan 2x, then this cannot be done. So it has to be done by method of variation of parameters only. But sometimes they give a very simple problem, 3 into e to the power of 5x. Do it by the method of variation of parameters. So in this case, even though you can do it by shortcut way, you have to do it by method of variation of parameters, because it is demanded in the question by method of variation of parameters. Then keep in mind, first of all we need yc, that this method is only helping us to calculate yp when you know yc. Again I am repeating the sentence. This method helps us only in finding yp if we know yc. So from yc we will apply the method of variation of parameters to get to yp. If you don't know yc, this method is of no use to get the method to get to yp. You can't get yp without knowing yc. So let me come back to the point. First of all, let us write yc. You know that roots are 1 and 3 for this. So c1 e power x plus c2 e to the power of 3x, and implies yc is c1 into u plus c2 into v. We call this u, okay, and therefore u is this much and v is e to the power of 3x. So once we are ready with yc, we will get what is u, what is v. Next what we do is we will calculate w, that is nothing but the Wronskian, okay, of u and v. First u and v, then their derivatives, that is nothing but u into v dash minus u dash into v, that finally should be not equal to 0. And because you are writing general yc, that two solutions will be definitely independent solutions. Suppose if it is c1 plus c2x e to the power of 2x, you have to take u as e to the power of 2x after separating, and v as x e to the power of 2x. I hope you got my point. So this is the way how you have to select u and v, and that u and v will be definitely independent, therefore you will get w not equal to 0. Now by method of variation of parameters, yp will be equal to a into this u, means whatever functions are used in yc, they will be playing the role here. So this yp is given by this one. Now the question comes, what is a and b, where a is equal to and b is equal to. What are the formulas to calculate this one? Keep in mind, in the denominator that w is there, and in the numerator r is there in both of them, r and w dx. Here minus u to be minus v, minus v is used, and here u is used. So what is this minus v? You understood, whatever v is there, you have to substitute this minus here, okay, minus into v you have to take it, or else I'll just write outside this particular minus. So you remember the formulas for this particular a and b, okay. So I'll simply write it as u here and minus v here, minus into integral vr. So r by w is available in both. Here a is using minus v, b is using plus u. How you remember? A and b in alphabetical order, u and v are in alphabetical order. Actually a should come with u, like that you remember, this is the way to remember. But a is not coming with u, it is coming wrongly, like that, wrongly you tell, okay. It's only to remember. So it's not coming in the same alphabetical orders, it is coming in a very different way, that is it is coming with v, because of which that opposite match we are writing that minus. This is only the way to remember, that is not the proof why it's coming. Proofs are available in the textbooks, if you want you can see it. Back to the point. So a is this one, so you have v, you have r. That r is nothing but the function on the right hand side. So 3 e to the power of 5x is r value, so right side function r. So minus vr by w dx, that integration, and similarly you will get b value. Substitute that a value and b value here, you will be getting the value of yp. So yc plus yp gives a general solution. Now the last concept, that is method of reduction of order. This is applied to problem of this type. D square means differential equation of this type. D square y by dx square, some function of x here, into dy by dx plus some function of x into y is equal to 0. Be careful, it is applicable only to homogeneous differential equation. So to get the general solution, to get gs of this number 1, equation number 1, we need, okay, number 1, we need one solution of equation number 1. If we know just one solution, we can bring the complete general solution by the method of reduction of order. So if one solution, say y1 of x, we need one solution, say y1 of x. So if one solution is available with us, how to get the general solution, that I am telling you now. that systematic simple procedures. First what you do is you calculate v of x, that is equal to, this is the formula given by that method, proof is available in the textbook. So y1 of x, whatever y1 of x you are having, square it, and e to the power of minus integral p dx. This p is this p, we are not using q in this particular method, that gets adjusted by itself. Okay, so 1 by y1 of x whole square e to the power of minus integral p dx, this is v. So you have to simplify this, you will get some v. After getting that v, you have to integrate this v with respect to x, you will get some function that call it as u of x. And third, the other independent solution, one solution is y1 of x, the other independent solution, the other independent solution is y2 of x is equal to u of x into this u, whatever you calculated into this one. Okay, because there is no space here, I'll write it in the next step. Okay, so solution is y2 of x is equal to this calculated u of x from second step multiplied with the first function, first solution. Okay, one solution y1 of x, you will get y2. Once we are ready with y1 and y2, then general solution is y is equal to c1 into y1 of x plus c2 into y2 of x. You don't have any yp here because that is right hand side equal to 0, homogeneous function, keep in mind. So once this is given to us, we will calculate this y2 by multiplying this y1 to u, where u is coming from integrating v, where v is first calculated by using this one. Okay, I think I have taken some more time, but I feel that I covered a majority of concepts which are very important from the examination point of view. Okay, best of luck for your examination. Thank you.